Welcome back. We got another session of Math That Matters for you today. And I want to start by asking you a question. It's an early pause and reflect. And the question is this: how many different types of financial scenarios would you say that we have kind of discussed so far? Not individual problems, but types of problems, categories of problems. Give me a pause and think and answer that. Okay, I just asked Pete in secret, but Pete, what'd you come up with?
I said 3.
Okay.
Yeah, how'd I do?
I'm hoping and thinking they said 3. What were the 3 that you were thinking of?
I was thinking simple interest.
Good. I'm going to write it down here. Simple interest. Okay, and we had 2 different formulas for that, right?
Yeah, I equals PRT and F equals P times,
Okay, good. And what was your other 2?
So compound interest, which was preferable, right?
Yeah, for sure. Compound interest. But we didn't have anything after compound, so how'd you get 2 out of that? Because you said a total of 3.
Yeah, I was thinking about repeating deposits.
Which is a subset, and that's the point I'm driving home. I don't want you to make the mistake of thinking that repeating deposits is not somewhere in here. I actually would have been okay if you said, I only have 2 scenarios, simple interest and compound interest. But there's 2 different kinds of compound interest problems, right? There's the single investment, right? Sometimes we call these lump sum problems, right? Which means that you're making one investment and you're getting one return out. And we know the formula for these. But it is clearly compound interest. But the alternative is what, Pete?
Repeating deposits.
Yes. Regular repeating deposits. And Pete, will you explain why this is classified under compound interest instead of its own category?
Sure, yeah. So with a repeating deposit, what happens is the deposit that you make grows according to compound interest, but usually it's not very much because you couldn't afford very much, and then you have to wait for a time, and then you put in that deposit again, and then it grows according to compound interest. So you actually have repeating compound interest problems that you sum up. And that's why this formula handles the sum.
Yeah, and the reason we wanted to start here is because although I hope you see a really clear distinction, because if you have a repeating deposit scenario, you can't apply this formula to it. And if you have a single investment, you can't apply this formula to it, right? These are separate, but they are together under the compound interest umbrella, all right? And the reason we're starting here today is to basically give you some good news, and that is it's really not that complicated. All the problems that we're going to encounter in financial mathematics largely will fit in one of these 3 categories. The trick is you just have to look at the problem and correctly categorize or classify it, right, Pete?
Absolutely.
So that's the challenge. So we're just going to jump into a couple problems that aren't so clear and let you try to see where does it fit? Does it go under this or this or this? Then you pick the right formula, put the variables in, and you're out of there. Okay? Let's dive right in and see how it works. Okay, so here's our first example that we'll try to classify in the correct category. We have a wise GFU grad, 22 years old, obviously a Math That Matters student.
For sure.
Decides to deposit $150 a month into an account that earns 7.5% interest compounded monthly for 10 years. At age 32, he stops the deposits, but he just leaves the money in the account untouched in the very same account. And the question is, how much will he have at age 62? So here's the pause and think challenge. Which category does this problem fit in? Okay, we're back, Pete. Well, what do you think they came up with? How would you answer the question?
I don't think you've asked the right question.
I agree.
Yeah.
I'm sorry.
I know.
I did it on purpose.
I know. I feel loved, though,
Yeah.
so that's okay.
Yeah.
Yeah, so I was looking at this, and the thing that's different about the ones that we've done so far is all of a sudden you stop, but you don't stop. You stop one thing, but you don't stop another thing, right? So you stop making deposits, but you don't stop that money from growing.
So this whole problem does not actually fit in any one
Not a single
of
category.
the categories. That's right. That's
So
the whole problem.
which category does it fit into first?
Okay, good idea. So you're talking about breaking the problem up.
Yeah,
Because if I said which categories does it fit in, would that be a fair question?
that would be fair.
Yeah, because we have 2 things going on. For 10 years, if I draw a little picture, we have repeating deposits going on for 10 years, right? And those would result in some kind of a future value, right? I'll call that F sub 32, because that's the future value at age 32.
Gotcha.
Right? What happens then, Pete?
Yeah, so then there's some money in the account, and that money retains its value, but it grows actually because it's still growing at 7.5% until age 62, 30 years after that.
Good. So would it be okay for me to say this becomes a sort of principle? The future value became a principle for another problem that went for 30 more years, but it was not repeating deposits, it was a single deposit.
Yep.
And it would be solved by that problem.
Future value at age 62.
So this is F equals D, 1 plus R over N to the NT minus 1 over R over N. So I've applied this formula to part of the problem. I've taken the result of that and put it into another scenario.
Yeah.
Let's go ahead and solve it and see how we do.
Let's do it.
All right, the first step in our problem is the very first 10 years where we have repeating deposits going on. This formula should look familiar. We got regular deposits of $150 a month at the specified interest rate over the compounding period for the specified compounding period times the time, and it wrapped up into $26,689. Notice I'm not going to boombox this because it's not the end of the answer. So you can't be doing booms halfway through.
No.
Don't do that. A little
It'd
boom.
be embarrassing.
Like
a little boom.
little boom like that. You
Maybe
can underline it. That's
baby-
all.
baby
Okay.
boom.
Now, what do we do with this though? This is not 62, Pete. This is 32.
Right, we've got 30 more years of this being a sort of principle in a compound interest scenario. Right?
Okay. So that's going to be
The next 30 years.
Next 30 years. So basically, I'm going from 32 to 62 in this wise person's life, and now I'm solving for F, 62
Future value at age 62.
equals the principal, 1 plus R over N to the NT, and I just wanted you to see that this is the principal for the second part, isn't it, Pete?
Absolutely.
So that's a better explanation there. So I've got 26,689, 1 plus 0.075 over 12. Notice the interest is the same. Nothing's changed there. But it is no longer 10 years. It's now 30 years of time. This was the first 10. That's the last 30. And this came out to be a whopping $251,000. 456. And you notice we're not putting the pennies because if you got $250,000, you really don't care how many pennies you have
can
at this
have
point. Yeah, keep the change, all right? So that's F62. Do I get to boombox this?
Oh, for sure.
Yeah,
Without
that is
a
it.
doubt.
Boom. Okay, that's it. Now, Pete, oh, nice. You know the question we got to ask, how much interest did I earn?
Right, because we want to know how much money did it cost us?
Yeah.
And how much money did we end up with?
I kind of thought earlier that the interest was a difference between future and principal, so could I just take the difference between these two and that's my interest?
I think I better be careful. Did we actually put this much money in?
No, that's the end of
didn't.
this.
Yeah, we
In
put
fact,
in.
that would be the interest for this half.
It would, but let's get the total interest, right?
like
Isn't
it.
that
Let's
what
go
we
for
want?
the whole thing.
So how much
how
did
do
we
we do this?
actually put in? 10 years at $150 a month. I think I could actually figure that out.
Oh, that's our regular, that's our sum of the D's,
That's right. So
right? So our principal or was a sum of deposits. That's what we put in, right? DNT. How
So
much?
$150
Okay,
times 12 times a year
yep.
times 10 years. That's all.
That's right, there was no more deposits, right? Because once he stopped making deposits, that's it.
150 times 120.
Well, oh man, I should be able to do that, Pete, but I don't have it here. Oh, wait, $18,000.
That's all. Wow. That only cost me $18,000 and I ended up with
I know.
251.
You and I are both thinking like, do we make a mistake?
know,
But
yeah,
think
you wanna
that's-
check your-
I think that's right,
That's,
Pete.
didn't Einstein say you've got the power of the world
This
at your
is it.
fingertips?
Let's
I
draw a
didn't
pie,
memorize
draw
it
a
well
pie
enough.
chart for this. The
Yeah.
pie is $250,000, Pete. It's $250,000. Now, 18,000. That's not even 10%
like-
of it.
That's a teeny tiny.
Yeah.
So we invest $18,000
$18,000.
and the interest is 250,000 minus 18,000.
We told you in our videos that this class can change your life, you guys. If you will apply some of this stuff, again, this is a long horizon. Remember our graph? This is a 40-year problem.
Yeah, you can only apply this one time.
Yeah, in fact, Pete can't apply this because he's too old,
Yeah.
and I can't apply this because I'm too old.
No, I might not even be able to apply the 10-year problem.
They can apply this.
Yes.
You guys, they can
Yes.
actually do
The
this.
smart people behind the camera.
Yeah, they can almost apply it. Yeah. So really powerful example of compound interest and how you can see it working. Okay. Now here's a fun scenario that we're going to set up, but we're going to have you solve it. Suppose that this guy went to his 10-year reunion at age 32, and he was popping off about how much money he's been investing, and at age 32 he's like, yeah, I got $26,000, and one of his classmates thinks, man, I haven't put any money away yet. And so they kind of got competitive, and they thought they want to catch up to him.
Okay.
So at age 32, they decided to start putting $150 a month, every month, into the bank to try to catch up to him. Okay. Now, what I want to know is if they put that money in for 30 years, not 10 years, but for 30 years, at 62, will they catch him or not?
That's a good question.
Yeah. What's your feel, Pete? What's your feel that if someone says, okay, I'm a late bloomer, I didn't get started, I didn't do any of this, but I am going to put $150 a month away for all 30 of these years because this guy's not depositing any more money, so he thinks he might catch up. Do you think he'll catch or not?
I would guess no, but that's just because this big seed that we plant into the bank is going to grow into something.
Yeah.
Anytime you can put a big bomb into the earth,
the
earth of investment, it blows up. And if you put little bits and pieces, so my guess is this is still going to end up with more, but I think that they should try to figure that out.
You're right, it is, and they are going to try it. We're going to give you the answer, but we want you to try this, all right? I did this, and I did, it's kind of going to get messy here though, $150 a month for 30 years. The exact same account, use the same interest rate to be fair here, apples to apples, and our question is how much will that be? And if I did it right, it's around $200,000.
Wow.
Yeah. You know, the irony is this person had to put in $54,000.
And ended up with 200.
Yep.
That person put in 18,000 and ended up with 250.
So if you're sitting there thinking, I'm going to wait and start saving later when I have money, it's the wrong game. The time is now, you guys. Make your investments now. You can do this. You actually can't catch up. This guy will never catch him. Yeah, it's kind of a depressing thought.
Yeah.
Unless you're this guy, you're thinking, hey, that's the way to go.